Hey everybody, this is the notes for 4.5. This is the last section in chapter 4, just so you're aware. This is linear inequalities, and systems of inequalities in two variables. So it's essentially all the work we've been doing, but because there's inequalities, because it's greater than, less than, greater than or equal to, less than or equal to, there's just an additional step to consider, especially when we graph. So when we're talking about linear inequalities in two variables, we're talking about the same format that we've been talking about all along. We're just using inequality symbols rather than an equal sign. A solution to a linear inequality in two variables is any ordered pair that makes the inequality true. Just like before, we can put in a point. If it makes it work, it's true. The difference is that they are not going to just be during the last few sections. What happened is the solutions were points on the line, right? What's going to change with inequalities is it's going to be a part of the grid. So I'm going to show you that. So we're going to graph this and graph the solution set. So for me, the first thing I'm going to do is put it into y equals mx plus b. So I'm going to move the 2x. So I'm going to get y is less than or equal to negative 2x plus 3. None of this process changes for graphing until the very end. So I know the slope is negative 2 over 1. I know the y-intercept is 0, 3. So I'm going to do that. So 0, 1, 2, 3. There's my y-intercept. And it's going to go down 2 over 1. Oh, sorry, down to right 1. I'll bring down to right 1, down to right 1, down to right 1. So here's my line, give or take. And now the trick is, okay, that when we graph inequalities, a couple of extra things happen, 2 to be exact. The first is we need to decide about our line. So when things are less than or equal to, greater than or equal to, all of the points on the line are included. So the line is going to be solid. When it's less than or equal to or greater than or equal to, they are not included. It's going to be dashed. That's one thing. Okay, so that's one thing. I made this a solid line because of the equal sign here. The second thing is that I have to figure out what part of the graph the answers to this inequality live on. So what I'm going to do is I'm going to pick 2 points, any 2 I like, on either side of the line. I'm going to pick one over here somewhere, and then I'll pick another on the other side. I'm going to erase those because I'll show you. Oh my, suddenly I'm starting to paint things. All right, so here's what I'm going to do. I'm going to pick 2 points. Let's say I'm going to pick 0, 0. So my red point is going to be 0, 0. And then I'm going to pick something else. Let's pick, I don't know, 3, 3. And then I'm going to test them in my equation. So I'm going to say 2 times 0 plus 0 less than or equal to 3. Well, 2 times 0 is 0 plus 0. 0 is less than or equal to 3. That's true. I should have done that in red, but forgive me. And then I'm going to test the other. 2 times 3 plus 3 less than or equal to 3. Let's see, that's 6 plus 3 is 9. 9 is less than or equal to 3? No. This one works, that one doesn't. So the red one works. What that means is that I'm going to shade this whole side of the graph because that is where all of the solutions to this inequality are. So any point on the red side that I pick any one you like, is actually a solution to this inequality. They're all the points on that side of the line, including what's on the line. So let's try another. So I have 3x plus 2y greater than or equal to negative 6. So the first thing I'm going to do is put y equals mx plus b, move the 3x. So I'm going to get 2y greater than or equal to negative 3x minus 6, divide by 2. So I get y greater than or equal to negative 3 over 2x minus 3. So I know that the slope is negative 3 over 2. I know the y-intercept is 0, negative 3. So I'm going to graph that. So let's see, 0, negative 3 is here. And then I'm going to go, I can't really go down and over too far, so I'm going to go up and to the left. Up to the left. So here's my line, give or take. Forgive my, it's a terrible line. That's better. There's my line. And now I'm going to test 2 points, okay? Oh, first I drew a solid line. So this is going to be a solid line because of the equal sign there. Now I'm going to test 2 points. So I'm going to pick 0, 0, that's on one side. And I'm going to pick, let's see, negative 4, negative 4. And I'm going to go back to that original equation. So 3 times negative 4 plus 2 times negative 4 greater than or equal to negative 6. That's negative 12 plus negative 8 greater than or equal to negative 6. That's negative 20 greater than or equal to negative 6. No. Now here's the thing. Don't automatically assume it's the other one, because if you didn't do the math right, you'll find out here. So 3 times 0, I'm going to actually do that over here because I don't have enough room. 3 times 0 plus 2 times 0 greater than or equal to negative 6. Well, 0 greater than or equal to negative 6. Yes, check. So the solutions to this graph lay on the 0, 0 side. That's the side I'm going to shade, okay? This is what we call the test point method. So you set up the equation, you graph it. If the original inequality is strict, it's greater than or less than, line is dashed. If it's not strict, equal to, it's a solid line. From there, we choose a point not on the line. On each side of the line, if it makes it true, then we shade that side. If it makes it false, we shade the other side. We always try one on each side. All right, so let's try another one. You could actually try this one yourself, see what happens. So I know right away this is going to be a dashed line because it's not got an equal sign. So I'm going to move the 4x to the other side. So that's going to give me negative 2y less than negative 4x plus 6. When I divide by negative 2, remember I have to flip the direction of the sign. So y is less than 2x minus 3. So then the slope is going to be 2 over 1. The y-intercept is 0, negative 3. Apparently that's a theme today. So I'm going to graph. So here's my 0, negative 3. I'm going to go up 2 over 1, up 2 over 1, up 2 over 1. Promise to make a prettier line. Up, and then I'm going to make it dashed, which is really hard to do on this screen, but I'm going to just put some erase marks in there. So I made my dashed line. That means the solutions are not on the line. Now I'm going to test 2 points. Let's do 0, 0. Come on. I'm going to do 0, 0. And let's try 3, negative 3. All right, so let's do 0, 0 first. 4 times 0 minus 2 times 0 greater than 6. I'm going back to the original equation, remember. 0 minus 0 greater than 6. 0 is not greater than 6, so that's not right. Let's see if it's the other guy. So 4 times 3 minus 2 times negative 3 greater than 6. Well, that's going to be 12, and then that's a plus 6. Greater than 6, definitely. 18 is definitely greater than 6. So I'm going to shade that side. Okay. You try the next one. This is same idea, basically. So I'm just going to put in the answer here. This y-intercept is 3, 0. The slope was 3/1. So it's about like this. And when you do your shading, it's going to shade to the left. So if you get stuck, come on into the discussion and let's talk about it. Okay, oops, sorry, this should be a dashed line. Also, I'm going to do that every time because drawing on this screen is tricky to make a dashed line. Okay, so let's try a different one. This one works a little differently, but it's not really different, okay? I'm just going to do ny equals mx plus b first. So I get y greater than or equal to 5/2 x. When there's no y-intercept listed, we know it's really plus 0. So the slope is 5/2. The y-intercept is at the origin, at the center. So I'm going to go up 5/2, down 5/2. There's my 3 points. I'm going to try to draw this line, and it won't let me. There it goes. So now on either side, I can't use 0, 0, which I tend to because it's straight through 0, 0. It's a solid line because of the equal sign. So I'm going to pick, let's see, that's on this side, it's negative 1. Negative 1, 1. On the other side, let's do 1, too many negatives in my brain. 1, negative 1. We'll do the reverse. So go back to the original equation. 2 times 1 greater than or equal to 5 times negative 1. Well, that's going to be 2 greater than or equal to negative 5. That's true. If I reverse it, 2 times negative 1 greater than or equal to 5 times 1. That's going to be negative 2 greater than or equal to 5. That doesn't work. So I know my solution is on that side. Okay. You try the next one. That's what we do here. All right. This one, I'm just going to draw in. You do the work. The slope is half. So, or sorry, negative half. So let's see. Up 1, left 2. So here's the line. And when you do the shading, you should be shading towards the bottom. Okay? If you're stuck, go into the discussion. All right. So let's try one more. This one only has one variable. So when you see that, your brain should go, oh, vertical or horizontal. Because it's an x equals, this is going to be a vertical line. So I'm going to have a vertical line at x is greater than negative 2. That means the line is going to be at negative 2. We know it's dashed, which is tricky to do here. I'm going to try it. And then I still have to shade. So I have to think to myself, well, where are the numbers greater than negative 2? If you think about that, on the graph, where are the x values greater than negative 2? They're to the right, right? So if you think about the x-axis as a number line, that's 1, 0, 1, negative 1, 0, 1, 2, 3. Those are all the numbers greater than negative 2. So that is the side I'm going to shade. You can test the point, but that's where you're going to come out at it. Let's try another one. Divide by 4. So this is going to be x is greater than or equal to 3. So again, vertical line at x equals 3. This one is solid. And think about where the numbers greater than or equal to 3 are. Well, they're over here, again, to the right. All right, let's try another one. This one, oh, this is where it gets tricky. This is the system, okay? So it doesn't actually get tricky. We just have one more step to consider. So in this system, we're gonna approach it just like we've been. We're gonna graph each line, set them up into y equals mx plus b. So I have less than or equal to negative. So I have two equations. I have this first one, I'm going to do in red, y equals half x minus 2. So let's do that first. The y-intercept's at negative 2, up 1 over 2, up 1 over 2, up 1 over 2. You want to draw enough of the line, okay, that they're gonna cross. I'll show you why. So there's the red line. Let's make the other one green. Y equals negative x plus 1. So the y-intercept is at 1, and it's going to go down 1 over 1. So I see where they cross. I see what my line looks like. And now here's the trick. The red line should have been dashed, so I'm going to make that so. Okay. Now, when we test points here, we actually test 4 points because before we had 2 sections. So we tested either side. But here you can see I have 1, 2, 3, 4 sections created by the crossing of my lines. I need to test all of them to find out what's going to work. Oh, that should have been a 2. So I have to go through and pick points in all of those places and then test them in my equations to see if they work. So I'm going to pick, let's pick this one. Let's pick 1, 2, 3, 1, 2. This is going to be 3, 2. In section 2, I'm going to pick 0, 0. In section 3, down here, I'm going to pick, let's see, that's 2, negative 3. And then over here in section 4, I'm going to pick 5, negative 2. And then you're just going to go through and test the way you've been testing, okay? So I'm going to start with section 1. I'm going to, oops, I can't see both equations. So I'm going to test one. I'm going to test them in both. So put 3 in for x. So half times 3 is, I should do this right out here. I'm going to make myself some space. Get rid of that. Okay. So y equals, so it's 2 greater than 1 over 2 times 3 minus 2. So is 2 greater than 3 halves minus 2? Well, 3 halves minus 2 is really just 1.5 minus 2. That gets me a negative half, or a positive, no, negative half. So does that work? No. So the minute you get a no, and you're sure about the math, it's not this section. You can move on, okay? So I'm gonna do the next one. So I'm gonna put in 0, 0. So 0 greater than half times 0 minus 2. 0 greater than half times 0 is greater than negative 2. That's right. So let's try the other one. 0 plus 0 less than or equal to 1. Well, yeah, that's true too. Okay, so those both work. So this is probably my answer. But you won't always get there right away. You can go through and check the other points. But when both equations are true, and they have to both be true for that to be your section, this is the section you're going to shade. Okay, get 1 out of the 4 sections shaded. All right, you try this one. So graph both lines, see what happens. So I'm going to graph the first one in green. So this in y equals mx plus b form is y less than or equal to negative 1. I'm moving my screen. 1/3 x plus 3. So I'm going to go up to 3, down 1 over 3, down 1 over 3, up 1 over 3. Okay, there's my line. Oh, did I do it wrong? Oh, is it a positive? It was a negative x when I moved it over, so this should be a positive. Sorry, that's what I get for trying to do math in my head. Okay, so I moved negative x over divided by negative 3 gets me positive 1 over 3. So there's my 3, 1 over 3, down 1 over 3, down. There's my green line. Okay, it is solid because it's equal to. And then I'm going to do my second one. I'm going to do that one in blue. So the y-intercept is 4, and the slope is negative 2 over 1. So down 2 over 1, down 2 over 1. Okay, now you have your 4 sections. Okay, 1, 2, 3, 4. Pick a point in each section of the x, test it. When you do, you should find that it is this section that the solution is in. Okay? All right, let's try another one. So this one is y is less than or equal to 3. Oh gosh, another dashed line. That blue one should have been dashed. Forgive me. Okay, going back. Y is less than or equal to 3, so that is a horizontal line at 3. A solid horizontal line at 3. Okay, and then this one is move the 2x, minus 2x. So I get negative y less than negative 2x plus 2. Divide by negative 1. Make sure you flip the sign. Y is greater than 2x minus 2. Okay, so then you graph the second line. We'll do that one in red. Starts at negative 2, up 2 over 1, up 2 over 1, up 2 over 1. You want the lines to cross. And then you're going to test your sections. That red line should be dashed. We will make that so. Okay. When you do test each part, I know actually the one trick here is that y is less than or equal to 3. The y's are less than or equal to 3. So I actually am, so if I number the sections 2, 3, 4, I know because of that y is less than or equal to 3 that there can't be answers in section 1 or 2 because they have to be less than or equal to 3, and those are on the bottom half. They're below that blue line. So I'm only going to test points in 3 and 4. And when you do, you'll find that the answers are here. All right. You do this last one. Vertical line at x is negative 1. This one is y equal, y up, vertical dashed line. Okay. This one is y is less than or equal to negative half x plus 1. Okay. So y-intercept at 1, down 1 over 2, down 1 over 2, 1 over 2. There's my second line. And here's the thing to remember. This top line, the vertical line, is x is greater than negative 1. Those are all answers here to the right. So I'm not actually, if I think about my sections, I am not going to test anything in sections 2 or 3 because I know the answers to the first inequality are to the right. So I'm only going to test sections 1 and 4. And when you do, you're going to find your answers are down here. All right, so this is the end of chapter 4. Keep going where you are in the modules, and I will see you in the next section.